n equal to 1. Okay, n equal to 1. Why? Sometimes it is expensive, okay, to take more than 1. Okay, because when in the inspection, sometimes you need to do destructive testing, for example. So you don't want to sacrifice too many products just for testing. Then you take only 1. So this is what we call it keyword control chart for individual measurement. Okay, so there are many situations that leading to this cases. So sample size for process monitoring is n equal to 1. Okay, so what happened is, for example, during automated inspection. Okay, so every unit in manufacturing is being measured and analyzed. No basis for rational subgrouping. Okay, because you are taking, for example, 100% inspection. Okay, so you have no luxury of taking more than 1. Okay, because it's everything is being measured. It's really 100% inspection. Okay, so and another situation is you don't have luxury of taking more than 1 because it's expensive. Okay, but the point number 1 here is we are doing 100% inspection, automated inspection, where every time you measure 1 by 1. Okay, so data become available relatively slowly. Okay, so this allow only sample size of n greater to 1 to accumulate. Okay, so this long interval will cause a problem for rational subgrouping, because if you take 1 sample now, maybe another 2 hours, another sample is available. So that timing can create a problem, okay, because the situation might change, okay, the temperature might be different. So the best way is we just use individual measurement for the purpose of monitoring the process. Okay, so repeat measurement. Okay, point number 3 is the repeat measurement on the process differ only because of laboratory analysis error, as in many chemical process. Okay, like chemical process is a continuous process. It's not a discrete process. Okay, so this is repeat measurement. Okay. Okay, number 4 is multiple measurement taken on the same unit of the product. Okay, such as measuring of site thickness of several different locations. Okay, so you may take 1 piece, but you are measuring at different point on the same piece, okay, different location. But the item you take is only 1. Okay, for example, you take measurement, okay, maybe at different corner of the workpiece. Okay, in process plant, so individual measurement are very common in many businesses, transactional business, service, and so on. So how do we do this? Okay, how do we do this? Control chart for individual unit. Okay, so what we do is we have what we call it individual control chart. Okay, so there are other charts. Okay, we will discuss later what we call it cumulative sum. Okay, cumulative sum, or what we call it Q sum. And another chart is we call it exponentially weighted moving average. Okay, which is also can be used for individual measurement, EWMA, exponentially weighted moving average. Okay, this is different than normal X bar chart. Okay, so before we go to that, let's see that individual control chart. Individual control chart, what we call it, we use moving range of 2 successive observations. MR means moving range. Okay, MR is moving range. Okay, we call it moving range. So we are measuring the difference between the current value minus the previous value. Okay, xi minus 1, meaning that two adjacent point. Okay, two adjacent point. I will show the example later on. Okay. Okay, this is this example now. Okay, read this example. Okay, this mortgage loan processing unit at a bank. Okay, we can use control chart also in services. Like in this example is a bank. The cost of processing monitor, the bank monitor the cost of processing loan application. Quality track is the average weekly processing cost obtained by dividing the total weekly cost, okay, of the loan process during the week. Okay, the processing costs for the most recent 20 weeks are shown in table 6.6. Okay, we have here week number 1, number 2, number 3 until week number 20. Okay, so what we have now is only one number, the cost. Week number 1, the cost is 310. Okay, we don't have moving range for the first number. In week number 2, we have 288. So the moving range, remember moving range is the current value, okay, current value 288. Okay, in this case, 288 minus 310. 310. So what we get is the magnitude only, the differences. Okay, so if you see this formula, okay, this formula, we have this, okay, we just take the magnitude of the difference. Okay, so this is what we call it moving range, MR. Okay, so we repeat the same. Okay, for the next one. Okay, for the next number we have 297. Okay, 297 minus 288. 288. So you have 9. Okay, so this is 9. Here is negative, but no problem negative. We just take the magnitude only. Okay, so we have 9 and we repeat, continuing. This and this, this and this, okay, this and this, and so on. Right? So finally, we get the summation of x bar, which is summation of all the observed or the data here. Okay, from the beginning, we get x bar with the average of this 20 number. So we get 300.5. MR is the average. This is average of MR 7.79. So now, how to prepare the chart? Okay, it is very easy here. Upper control limit is just x bar plus 3. Why 3? Because we are using plus minus 3 sigma, which is 99.73% of the point when the process is stable will be within control limits. Okay, we use 3. MR, okay, the average of MR divided D2, this is like sigma, the sigma value. So we have the central line and the lower control line, control limit. So this is like what we are having normally. Okay. So now this is X bar, not X double bar, X bar, because this is individual control chart. So this will be X bar plus 3 sigma. Okay, the sigma here is given by MR of average of MR divided by D2. D2 is coming from the table. Okay, so the lower control limit is just opposite of it. Change it to negative. So now we have MR divided by D2. Okay, so it's very easy. And then we plot. So what we plot inside, okay, what we plot inside the chart. Okay, so what we plot, we are plotting some points here inside. What we plot is, we plot this value, what we call this, the MR values. Okay, the MR values will be plotted. Sorry, hold on. what we plot is not the MR. We are plotting the X value. Sorry, the X value will be plotted, the individual values. Okay, so we plot individual values. Okay, we plot individual values. Individual values. Okay, if we see in this earlier example, okay, so what we have here, okay, these 20 individual values, okay, 20 individual values. The first one is 310, okay, we see 310 here, okay, 310, we plot this value. The second one is down, going down, 288, okay, 288, and then it move up, okay, so this is individual values, okay, individual values we plot. Okay, this is what we get from our calculation, the average, and this is the lower control limit. Okay, for the moving range, okay, we have this MR. Okay, this is MR. So what we plot here is, okay, the MR values. The MR values for the first one was, I think was 19, right? We have that 19, sorry, 22. Okay, so the first one was 22. Okay, so you see here, we start with number two, number two. Now there is no number one. Okay, because number one was not available, the earlier one. So we start number two, number three, number four, until 20. Okay, so this is the MR value. Okay, moving range. Okay, moving range. So in this chart, we have X and MR chart. Okay, so okay. So how do we determine this then? How do we determine this? This one is the average of MR. Okay, average of MR. You can get it from this table. Okay. Okay, this from this table you can get this value MR. Okay, I forgot to explain just now. In the case of D2, D2, when we want to use D2, okay, we need to know what is the N value. The N value. In our case, don't confuse, N value is not this 20. This 20 is basically the group subgroup number. I think your book use M, or sometimes I use it as G subgroup. Okay, M is 20. Or if you use G as subgroup, so meaning that G is 20. So the N in this case is equal to 2. Okay, so we use D2 taking from table. Okay, from table. So let me show you the table. I think you have that table also in your first exam. So I think at the appendix, somewhere in the appendix also got this table. Okay, do we have this table? The appendix. Okay, if I search it here, okay, control chart vector. Okay, do I have it somewhere? No. Table vector. Wow, cannot find it. Okay, anyone have found this table? Or maybe from the content of this book. The appendix. I think there must be explanation of the appendix. Explanation on appendix. Where do we get? Okay, if you found the table, please let me know. So I don't have to waste time here. Okay, index, we have the index. There's no table. There's no table. For appendix here. Standard table. Factors. Okay, factors for constructing variable control chart. So it is on page 720. Okay, page 720. Okay, let me go to page. I think maybe page, yeah, maybe let's be very close to 200. No. 750. Okay, how, right, 720. Yes, this is the table. This table is very important for control chart. So we are having all the factors in this table. You see here, factors, okay, for constructing control chart for variable. So we have control chart for averages, okay, which is for X bar chart. Okay, this is control chart for standard deviation, which is S chart. Okay, so this central line, and this is control chart for range, okay, for R chart. Okay, we have it here. So this is factor for central line, factor for central line. So just now we see that the factor for our chart, we have D2 just now, right? Where is D2? We have here. Okay, this is D2. Okay, so based on n values, okay, we select the right number here, 1.128. Okay, because n is 2. But for X bar chart, normally we use 4 or 5. Okay, 4 or 5. If 4 and 5, we take this number then. Okay, it's 4, this is for 5.
Excuse me, Doctor.
Yeah.
Kenapa N kita 2?
And kenapa N2? Because this is a moving range. We are taking only one sample, right? We are taking one sample, but to get the moving range, we need two values. Okay, two values, because we are comparing the current value and the earlier values. This is where you are having individual control chart. Without two values, we cannot get the R. Okay, so the techniques used here is, we call it moving range. So to get the range, we need at least two values. Okay, that's why n is equal to 2. Is it clear?
Okay, Doctor, clear.
All right. Okay, I go back to page, I think 280, somewhere there. Right. Okay, we have here, don't confuse with this one. This is saying that the sample size. The sample size, I think that's great confusion. This sample size here is where we are taking the sample for the purpose of process monitoring. But when we use the control chart, okay, we are using, okay, individual control chart with moving range. Okay, so the moving range, in order to produce this chart, we need at least two values for moving range. Okay, remember that X I minus X I minus 1. We need that the current value minus the previous one value. So this the difference is 22. The next one, you are taking the next value, which is 288n. So the n is going down like this. Okay, the n for the purpose of constructing the chart. Okay, don't confuse. The n, you take the sample, and the n that you use for constructing the chart. Okay, this is two values. Okay, the difference of this is 9. The difference of this and the next one is 1. Okay, so this is what we call it MR, okay, moving range. So if you see here, the solution here, okay, we get the average, okay, we get the average of MR, okay, MR was 7.79, okay, so this 7.79 is coming from here, summation of all the values, the summation of all values divide by 20, we get 7.79. Okay, this is what we get it, MR values. So we get that MR, and okay, we also need to know this the MR chart, the moving range chart. Okay, so the moving range chart. Okay, so what we do is we use this formula. Okay, this formula. Okay, what we have here, the moving range. Okay, the moving range. Okay, D4. Okay, and this is what we have it, D4. This one is D4. Okay, D4 multiplied by MR. Okay, D4 multiplied by MR. Okay, so how about lower control limit? Lower control limit is not so important. So it is normally, if we get it negative, we just make it 0. Okay, we just make it 0. So if you see here, this formula is for X chart. This is X chart. Okay, this is X chart. Okay, I've explained earlier how we can get. This one is for our control limit X chart, and D here, okay, D here, D2 from the table, where n equal to 2. Don't confuse with the n equal to 1, because we are using the 2 values for this example. Okay, so the lower control limit, the difference is only the symbol here, minus. Okay, this is where you get it here. Okay, where do you get this one? This value. So this X chart. Okay, don't confuse. This is not X bar, X chart, and this is moving range chart. Okay, moving range chart. Okay, moving range MR chart. So what we plot here is MR. What we plot here is X values inside. Okay, what we plot is we plot X. Here we plot MR. Okay, so start with number 2 and so on. Okay, so please go through this. Okay, so it's clearly stated here for moving range n equal to, so D2 is 1.128. Okay, so it's very simple chart, very simple chart. Okay, phase 2 and interpretation of chart. I think we have discussed this before. We need 2 phases, 2 phases of when we prepare control chart, especially at the beginning of any control charting procedure, the process is unstable. So what we do is we remove the unstable point, assuming there is assignable cost, and we recalculate again. Here we calculate again the center line and the control limits. Okay. Right. So in this one, okay, once we have a process is stable, we can use it for monitoring, okay, the following process. For example, in this one, week number 21 to 40, okay. So we have week 21 to 30 here, and then week 31 to 40. So when the process is stable, we can use that for the purpose of future monitoring. So what we see from earlier process, is there any problem or not from this plot? Is there any problem from this plot? You see any? Okay, this is not considering the pattern, just considering the normal rules where the point is outside control limit. There is no point outside control limit, right? So when there is no point outside control limit, so we can assume the process already stable. Okay, the process already stable. You see, we use the same control limit 321.279. Okay, the same as earlier. Okay, the same chart, because the chart now showing the process is in control. Okay, so but when we plot, continually plotting, we found that one point, I think 1 point, yeah, we found that something is wrong with this. Okay, so action need to be taken. Okay, that is out of control limit, showing that there is assignable cost. Assuming assignable cost, we investigate that. So this is where we do it for the using a stable process established using stable data. We establish control limit and use that for monitoring the future process. Okay, so let me move on to another topics on this individual where we are having okay, I hope that you read on your own all these summaries and application. Okay, later on I will assign a few exercise here. Okay, we have some example here. Okay, please go through this example. Okay, we have the example here is for example, you are having this component. Okay, you are having a component here and aerospace casting, for example. Okay, so using this, some data have been gathered and plotted. This is the X bar and S chart, example X bar and S chart. And also you can also plot the individual chart here. Okay, the individual, the moving range, the S chart, and so on. Okay, so I will assign you a few example, a few exercises here for you to test your understanding on this. Okay, let me quickly go to EWMA control chart, EWMA control chart, which is also a control chart for individual. Okay, so I think this is on chapter 9. Okay, chapter 9. I move to chapter 9. Here is chapter 8. Okay, cumulative sum and weighted moving average. Okay, cumulative sum, or we call it Q sum, control chart. And we have exponentially weighted moving average. Okay, as I said just now, E, W, and A. Okay, so this is different than Shewhart-based control chart. Okay, why we need this chart? Because this chart have more sensitivity. Okay, so why? What are the disadvantage? Okay, the disadvantage of Shewhart control chart is that it uses only information about process content in the last sample observation. Okay, so this is the limitation of Shewhart control chart. Shewhart control chart only use the information in the last sample observation. That is where decision making is done, unless we are using the runs rule. The runs rule is we are using more than 1 point to make decision. Okay, so because of this, based on the 1 point, okay, this is referring to when we are talking 1 point outside control limit, not referring to the runs rule. So this creates insensitivity of the chart to small process shift, okay, on the order of about 1 point. When we say small shift, okay, so 1.5 sigma or less. Okay, this is because small shift. So if we have 1.5 sigma and above, so we are considering that as big shift. Okay, so Shewhart control chart is less useful in phase 2 monitoring, where the process to operate in control. Okay, so we need to get a better charting procedure. Okay, one approach is, as I said, QSUM or EWMA. Okay, so what we do in QSUM? Okay, let me show you this example. QSUM, or we call it cumulative sum. Okay, cumulative sum. So this advantage of cumulative sum is the historical information is embedded in the following data. Okay, so okay, this is example. Okay, if you are given this number, okay, let's say you have this sample and this is the measured values. Okay, the measured values for 30 data. Okay, for 30 data, you are having this data. Okay, 30 data. Okay, and then you plot it in this chart. Okay, you can plot this in this chart. So we will see that. Okay, okay, this is Shewhart control chart for individual value. This is basically S chart. Okay, S chart. Okay, we see in this chart, all the process are in control. All are in control within control limits. Okay, but actually, what happened to this process? Okay, I'm showing this data, 30 data from this table. Okay, from this table. So what actually, what do you observe in this chart? What happened to this? What happened to the mean? What happened to the mean of this? Okay, you can respond to chat box or you can just on your mic. I want to hear you. Okay, what happened to the mean of this data? Is there any change or not? Okay, please put your opinion in the chat box. What do you observe? What happened to the mean? Mean, yeah.
Shift slightly above
Okay,
from
shift.
10.
Yeah, it's slightly shift. Okay, so the mean is shifted. Okay, the mean is shifted. Okay, if we don't look carefully, we don't realize this. Okay, it's shifted actually. So over this range, okay, over this range, you can see that the mean was 10. But after this point of 20, the mean have shifted. All the numbers above the central line. So the mean become 11. Okay, so when we monitor this, we say that the process is in control unless you are using runs rule. Using runs rule, you may detect this point. In order to eliminate or to overcome this limitation, okay, so researchers have come up with another method of monitoring this. So what they call it, QSUM control chart. The same data, but plotted on QSUM. You see the difference now? This is what is plotted on cumulative sum. Okay, the cumulative sum are able to show the difference. Okay, I will show the formula later on. If you see here, okay, this part is the mean is 10, but this part the mean, okay, is 11. Okay, so but okay, we see that drastically increasing. Why? Because have cumulative sum. So what is cumulative? Cumulative of deviation. So the Q sum is more sensitive. Okay, so it's more sensitive compared to Short chart. Okay, of the same data, the data is the same. So how do we do this? So we need to understand is what we call it, getting these cumulative values. Okay, so in cumulative sum, okay, so this is the C values. Okay, we need to have what is the C values. What we are plotting is the C values. Okay, which is xi minus 10. What is the 10? 10 is the center. Okay, which is the mean. Okay, the mean of the process. Here we are monitoring the process mean. Okay, the natural distribution with mean mu equal to 10 and standard deviation of 1. Okay, so what we plot, okay, if you see here, x minus 10, okay, 10 is the mean, the mu is equal to 10. How do we get the mean? It's the mean of the process from the stable process. Okay, so 9.45, okay, minus 10, you get minus 55. Minus 55 plus C I minus 1. So we don't have the previous value. We don't have the previous value for this C. So we assume it is 0. We assume it's 0. So it's the same. So the second value, if you see the second value now, this second value, okay, this one, okay, xi is minus, sorry, xi is 7.99, 7.99, okay, minus 10. And now we have to use the value of C. Now we are I number 2. 2 minus 1, meaning that C number 1. C number 1 was, okay, minus 0.55. Okay, so this is minus 0.55. So this is the value that we get from here. So from here you got 2.1, okay, 2.01 plus 2. Minus, okay, you have it minus, you have minus 2.01, okay, minus 0.55. Okay, so this is what you get, minus 2.56. Okay, this is what you get, the second value. Okay, continue with the rest of the values. Okay, using this formula, of C. Where is that? Okay, using this formula. Okay, using that formula. So when we plot this, you see the value here. When we are keep using that formula, the value is keep increasing, especially this part. Okay, starting from this point, where the shift is already happened. Okay, the process has shifted. So if we plot here, you cannot see. You cannot see. But when we plot using the Q sum, okay, we see this. Okay, we see the increase. So this advantage of using cumulative sum compared to X chart. Okay, use the X chart. So, and this is the understanding of how the cumulative can be used. But this chart, okay, can be modified, what we call it tabular Q sum. Okay, tabular Q sum or VMAS. Okay, we call it VMAS of Q sum. Okay, so tabular or arithmetic Q sum. There is a slightly different formula here. So this is where we get the tabular Q-sum values, which is C plus and C minus. Okay, so we need to use this when we use tabular Q-sum. Okay, so the advantage of tabular Q-sum, we even can have these different K values. Okay, what is K value is called reference values or allowance of the slack value. Okay, so we can have this, for example, here, the same example that you have seen earlier, but in this one, we have the period xi, and this we have done it earlier, but the different now we have C plus and we have C minus here. Okay, C plus and C minus, which is coming from this formula. Okay, C plus and C minus. So using this formula, okay, we calculate all these values. Okay, this data is the same, the same as previous data. Okay, the only addition here is you got it C plus or C minus. Okay, using the earlier formula. So when we plot this, you're going to have okay, let me show. There is no showing here, but anyway, it shows here is it shows here is the Q-sum status. Okay, Q-sum status. Okay, manual plot. Okay, we can see that C plus and C minus. Okay, so this is the C values. We have the C value up and down. This is H is like a control limit. We can set this H, what H that we want to detect. So still within, but after this point, you can see that the cumulative sum, the dotted line is actually the original values. Okay, the original values without Q-sum. We cannot see, okay, the cumulative. We cannot see the cumulative. The line is just fluctuate. Okay, but when we count the C values, we see that these C values hit this. So this is where sensitivity of Q-sum is very important. Okay, so the second chart here is showing the C plus. Okay, this is the C plus, and this is showing the C minus. Okay, C minus. So this detection is happening there, okay, which was not able to detect by a short control chart. Okay, I will continue discuss this. Okay, and I will identify. Okay, next week is I think no class, right? You have semester break, and I will give you a few exercise for you to practice this. Okay, so okay, there are a few more issues when designing this, where we have V shape of Q-sum, the Q-sum that is getting the stability and so on. All right, any question before I finish? Okay,
No.
Okay, can someone summarize what we learned today? What do you understand from this lecture? Any volunteer? Or can put it in chat. Okay, what you learned? Just put it 1 or 2 lines. Okay. Nobody respond. Please respond before we end the session. Okay, what you learn? Please. Okay, learning about moving a range. Okay, short control chart and Q-sum. Q-sum better than short. Okay, good. Okay, please others just put 1 line what you remember. Okay, EWMA, Q-sum more sensitive, Q-sum is more detailed. Okay. Okay, so basically we learn about using a control chart for individual values. Okay, individual values. We have X chart and we have moving range chart. Okay, where n is equal to, we use n equal to 2 for MR. Okay, but actually we are taking only one individual sample at any time. Okay, with that, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.